Project 3.1.1 CHUMP Clock, Counter, and Code. The objective of this stage is to create a clock signal for the rest of the 4-bit processor and a 4-bit signal to drive the rest of the operating devices. Additionally, a program is to be created in this stage to be implemented in the next. The clock signal is created by either one of two of the 555 timers. They are in order from left to right: astable, monostable, and bistable, which is used to select between astable and monostable. This is a circuit diagram of the 555 timers. The astable clock on the left is the most familiar, as it was discussed in Project 2.1 last year. The monostable clock in the middle is essentially a button debouncer. It uses a push button to create an output signal on the output pin. The bistable clock on the far right is essentially a switch debouncer. It uses an SPDT switch to determine the signal on the output. These clock signals from the 555 timers are then fed into a NAND logic circuit. The diagram here is color-coded. The yellow signal comes from the astable clock, the green signal comes from the monostable clock, and the black signal comes from the bistable clock. At its most basic level, this circuit is designed to select the clock signal that is used according to the signal coming from the bistable clock. The halt line at the very bottom, HLT, is used to cut the signals coming from the clocks at a certain point and is implemented in a later stage of this project. The clock signal from the NAND circuit is then fed into the program counter, which creates a 4-bit signal that increments after each clock pulse. Otherwise, it can also create a 4-bit signal according to its input lines, which are shown by the switches if the load signal is low. Writing a CHUMP program is different from writing an Arduino program in that it has no IDE. Therefore, it can be written on basically anything. In this format, it uses a table with high-level, machine-level, CHUMP assembly level, and a comment. What you see in the high-level column is meant to mimic what you would see in an Arduino IDE program. The address is the equivalent to the output signal from the program counter. The instruction is made up of 2 bytes. The most significant byte, or the leftmost bits, are used to define the instruction, and the rightmost bits, or the least significant bytes, are used to define a constant or a memory location. The CHUMP assembly level column translates what's written in the machine level instruction into something that we can comprehend, and the comment explains what the program does in further detail. For more information about this project, see my extended video. Thanks for listening.